Cool. All right. So, you ready? All right. So, we have two things here, right? I have a table. I'm going to draw a table for you, and we're going to look at, excuse me, the differences in rate of change. Okay? All right. So we have the side length x. We have perimeter y, and then triangle square. Okay? So perimeter y.
This is length x.
Huh?
This is length x.
Yes, sir. It says length x. And then triangle and square. Triangle and then square. Now I'm going to draw the values for you, okay? So, 0, 2, and 4. 0, 2, and 4. The values underneath the triangle are going to be 0, 6, and 12. And then the values in the square are going to be 0, 8, and 16. All right. With that being said, we need to find out, we need to show how the perimeters of an equilateral triangle and a square change as side length increases, okay? We got to compare our rates of change. That make sense? All right, so now we're going to look at our triangle rate of change first. So triangle rate of change. That equals change in y or change in x. All right, and consequently, what is our change in y for the triangle? How many units is it?
What?
If you look here at our triangle, how many units is that? What is the change?
That's
Hmm?
12.
So 0 to 6 is 6 units, right?
Yes.
And then, yeah. And then 6 to 12 is 6 units.
Change in x is 8.
Huh? Right, yeah. So it's 8. So on the other side. So we have 0 to 8 is 8 units, and then 8 to 16 is 8 units, right? Does that make sense so far? Yep, looks like the call dropped. All right, you're back. Can you see me?
No, you just. Yeah.
Hold on, I'm coming in. You see me now?
Okay.
All right, cool. So change in y or change in x, we have our 6 over 2. Right, if you look here, our change in x is 2 on this part. So we have 6 over 2, and our rate of change is going to be 3. That is for the triangle. Now let's look at the square rate of change, okay? So square rate of change is going to be change in y again over change in x. But now, so what exactly happens now that we have change in y and change in x on the square side of the house?
So the top number just changes, or y changes.
Say again?
Y changes.
Y changes, right? So now we have, instead of doing the 6s, right, we got 8. All right? But now we have 0 to 8 is 8, 8 to 16 is 8, 8 over, again, 2, 2 to 4. So 8 over 2 is how much?
8 over 2.
Yeah. What's 8 divided by 2?
Oh, 4.
4. All right, that's the rate of change of the square. So now, the perimeter of the square looks like it increases faster than the rate for the triangle. Okay, a steeper line is going to ensue from that. So as we draw our x and our y, Okay. We're gonna have, huh?
You don't simplify it?
What do you mean?
Because, like, you know how it's 8 over 2, you don't simplify it?
No, we did right here. 8 over 2 equals 4. You see it?
But does compare mean, doesn't it mean subtract?
Compare means for us, well, we did. That's what we did. We actually found that out, and our rate of change was comparing and subtracting our change in y and change in x. But now we're going to look at the actual steepness of the graph that shows how we can compare the rates. Does that make sense? Huh?
It's starting to freeze again.
Okay, let me go ahead and check that out. And I'm going to go ahead and write on the board the next steps for you, okay? All right.